Therefore, to summarize the whole program for binary search, you see that we will start with the low equals to 0, high equals to the highest index, and then create a middle variable to help us calculate the middle value. In the while loop, now you should understand, as long as we make sure low is less or equal to high, indicating we have a legit search space, we will calculate the middle value and then look for the 3 cases. We will repeat the whole process. As long as it's inside the reasonable search space, we will continue looking. If it is outside of that search space, which means low is greater, you can see that equal is still here, so it's still a legit while loop operation. So when low is greater than high, it is when the elements indicating not existing in the array. So we will come into, if that's the case, we will come to return not found over here. To analyze this program, you will understand that for every single comparison, we threw half of the elements away, indicating that's not possibly be the space because this is a sorted array. Think about this. If you have 1 million items, by doing one single comparison, you can ditch 500,000 of the items away and then understand that either the left side of the middle index or the right side of the middle index is the elements that you need to search for. With another comparison, you threw 1/4 of the median away. And that is, again, by doing one single comparison. This search will be much faster than you do a sequential search by writing a for loop search for every single item. So you can see that comparison with the sequential search is a big O of n operation. For the binary search, you basically will reduce the search time from big O of n linear into log n. And this log is basically log 2 based n to help you understand the power of the log n. To make sure you fully understand the whole program, I have designed a small assignment for you guys to work on, and this is something that you need to submit via the Blackboard. So let's take a look at this. Assuming that the array A is given in this case, again, it's a sorted array with 10 elements, simple as that. X equals to 19, which is some elements that we want to search for. And obviously 19 is not existing in this example. So I want you to use the same program that we have discussed with just one modification. I have a cout over here. So let's take a look of this program again. Design the low index, high index, and create a middle variable. While low is less or equal to high, we will calculate the middle value. Whenever we finish this line, we will have a middle value, middle index available. So all I want you to do is simply output the middle value, which in this example, we will have 0 plus 9 divided by 2, which will give us an index of 4. After that, we find the middle index equals to 4. We output 11 so that we will be able to get that value. And ENDL, of course, is going to the next line. And then we will do our basic binary search. So this is the only code that injected into this whole program. It will generate all the outputs whenever you search a middle index, and you will output the middle value of that index. I want you to show me what is the output of the whole program when it will stop and it will finish its operation. And of course, you know that it will finding not found in this assignment. So there will be several outputs, and I want you to submit what are the exact outputs of this program.